In this video, we will talk about quadratic inequalities. A quadratic inequality is an inequality that contains a polynomial of degree 2 and can be written in any of the following forms. It is easy to identify quadratic inequalities from quadratic equations. Since both are quadratic, the highest exponent of the variable x is 2. They just differ in symbol. Quadratic equations involve equal sign, while quadratic inequalities use greater than, less than, greater than or equal, and less than or equal. Study the following examples. The first example is a quadratic equation. It uses the symbol equal, and the highest exponent of the variable x is 2. The second example is quadratic inequality. Since the highest exponent is 2, and it uses the symbol for inequality, therefore, it is really a quadratic inequality. The third example is also a quadratic inequality. It uses the symbol less than or equal, and the highest exponent of the variable is also 2. The fourth example is a linear inequality, since the exponent here of the variable x is 1. Example number 5 is a quadratic inequality. The expression to the left is transformable into quadratic. Let us check your understanding. Let us move on in solving quadratic inequalities. It is important to have knowledge in solving quadratic equations and able to solve quadratic inequalities. In this lesson, the following steps will be used to solve quadratic inequalities. Let us find the solution set of x squared plus 7x plus 10 greater than 0. The first step that we need to do is to change the inequality symbol to equal symbol. In short, we will be converting the quadratic inequality into quadratic equation. So we will have x squared plus 7x plus 10 equals 0. And then we will find the solution or solutions of the quadratic equation. You can use any method that you want, but in this problem, I will be using the quadratic formula. And the value of x is negative 2 or negative 5. And for the second step, we need to plot the solutions on a number line. These points separate the line into 2 or 3 intervals. all you have to do is to plot our solutions or solution in this manner, wherein the lower or the lesser value should be here in the left side and the greater value should be on the right side. Negative 5 and negative 2 serve as boundaries, forming three intervals: 1, 2, and 3. Now, we will name the intervals and test a number from each against the inequality. We will also test the boundaries in this step. You can follow this pattern in naming the intervals. Take note that the negative infinity symbol here, as well as the positive infinity symbol, the less than symbol, and x are always given. The number line consists of all real numbers and extends infinitely to the left and to the right. The points or roots of the corresponding quadratic equation separate it into intervals. X represents corresponding value in each interval. It represents all the numbers in this interval or all the integers in this interval. Now, we will select a value of x in which we think the easiest to substitute in the original inequality. So, in this problem, I will be choosing negative 10. Because 10 is less than negative 5 or between negative 5 and negative infinity, it is possible for us to choose this number. You can use negative 11, negative 12, negative 30, or any number as long as it is between negative 5 and negative infinity. But for me, negative 10 will be easier for me to solve with. In this interval, I choose negative 4. Negative 4 is between negative 2 and negative 5. So, it is possible for me to use this number. You can also use negative 3 if you want. And in this interval, I will be using 0. My suggestion is, if you can use 0 in any interval, solving will be easier. And for the boundaries, we will have this answer. Take note that the answer here will always be 0 because negative 5 and negative 4 are the solutions of the quadratic equations. Now, the solution set of the inequality are the intervals tested as true against the original inequality. So, which of the following intervals tested as true? Of course, 40 is greater than 0, so it is true. Negative 2 is not greater than 0, so it is false. And 10 is greater than 0, so it is also true. So the answer or the solution set in our inequality is the interval where we tested true. Or, by writing these two inequalities or interval here and placing or between, this is now our solution set. X could be less than negative 5 or greater than negative 2. Now, for our boundaries, which are negative 5 and negative 4, they are not included in the solution because 0 is not greater than 0, as well as the answer here. So if you notice, we will not put an equal sign below the less than symbol. We can also represent the solution set using a number line. The two circles are hollow to indicate that negative 5 and negative 2 are not part of the solution set. All the integers less than negative 5 and greater than negative 2 are the solution set and represented by the thicker lines. Let us have another example. First, we need to change the inequality symbol to equal, then find the roots. The roots of the resulting equation can be solved by any method, and the quadratic formula will be used in this example. In the second step, we will plot the solutions on a number line. These points separate the line into 2 or 3 intervals. All you have to do is to plot the solutions where the lower number will be on the left part. Values other than these points are not necessary. So in this example, our boundaries are -2 and 10. In the third step, we need to name the interval and test a number from each against the inequality. We need to test the boundaries too. Just follow this pattern in naming the intervals. The number line consists of all real numbers and extends infinitely to the left and to the right. The points or roots of the corresponding quadratic equation separate the line into intervals. X represents the corresponding value in each interval. Select a value of x in which you think the easiest to substitute in the original inequality. I choose -10 since it is less than -2 and greater than -infinity, and also the easiest to solve for me. And in this region I use 0 as 0 is less than 10 but greater than -2 and also the easiest to solve for me. In the last region, I use +20 to obtain this answer. And for the boundaries or the solutions, this will be our answers. If you notice, the answer here is equal to 0. Because -2 and 10 are solutions of the quadratic equation. In the fourth step, the solution set of the inequality are the intervals tested as true against the original inequality. So, if the value of x here was tested true, therefore, the solution set of this equation will be in this region. X is less than 2 or greater than 10. +10 and -2 are not also included in the solution since they were also tested as false. In step 5, we need to graph the quadratic inequality on a number line. The two circles are hollow to indicate that -2 and +10 are not part of the solution set. All the integers less than 10 and greater than -2 are the solution set and represented by the thicker lines. In this example, we have the inequality symbol less than or equal. The first step is to change, of course, the inequality symbol to equal. The roots of the resulting equation can be solved by any method. As you can see, I use the quadratic formula. Now, we need to plot the solutions on a number line. These points again will separate the line into 2 or 3 intervals. In this case, we have 1, 2, and 3 intervals. -1/2 and 3 serve as boundaries. In step 3, we will name the intervals and test a number from each against the inequality. We will test the boundaries too. You can follow this pattern in naming the intervals. The number line consists of all real numbers and extends infinitely to the left and to the right. The points or roots of the corresponding quadratic equation separate it into intervals. As I said a while ago, we have here three intervals. In this interval, I will choose -1. Since it is less than -1/2, I can use -1, and it will be also easy for me to solve for the equation or for the inequality by substituting -1 in the value of x. And in this interval, I will use 0. 0 is less than 3 but greater than -1/2. And in this last interval, I will be using +5 since it will be easy for me to substitute 5 in our inequality. For the boundaries, we will have these answers. And for the step number 4, the solution set of the inequality are the intervals tested as true against the original inequality. As we can see, if the value of x is 0 and it lies in this interval and we tested it as true, therefore all the solutions or all the values or integers in this interval will be the solution set. And take note also that upon checking, -1/2 and +3 were also tested as true. The solution set is this: all the values less than or equal to -1/2 and greater than or equal to +3. Take note that -1/2 and 3 are part of the solution. Instead of using less than symbol here, we will be using the less than or equal symbol because -1/2 and 3 are part of the solution. So x could be equal to 3 and -1/2. And if we graph this quadratic inequality on a number line, we will have this answer. The two circles are shaded to indicate that -2 and +10 are part of the solution set. All the integers less than or equal to 3 and greater than or equal to -1/2 are the solution set and represented by the thicker lines. Let us solve this problem involving quadratic inequality. Mrs. Reyna is planning to fence her vacant lot for a parking space. The desired length of the lot is 6 meters longer than its width. What will be the possible dimensions of the rectangular parking space if it should be less than 40 square meters? In solving this kind of problem, it is important for us to identify first all the given. In our problem, we will have the area of the parking space, which is equal to 40 square meters, and the length is 6 meters longer than its width. We will represent the width as letter x. For easier substitution, we will have the area as 40, and since the value of the length is 6 meters longer than its width, and the width is equal to x, by adding 6 to x, this will be the value of our length. The formula in solving for the area of a rectangle is length times width, but in the problem, the area should be less than the area of the parking space. By substituting the first equation in this inequality, we will have now our formula. The length times the width is less than the area of the parking space. If length is x plus 6 and width is x and the area of the parking space is 40, we will have this inequality. And by simplifying, the quadratic inequality could be solved. The first step in solving quadratic inequality is to transform this inequality into an equation. So this time, our equation will be x squared plus 6x minus 40 equals 0. And by solving this equation by any method, you will have x as 4 and negative 10. Let us plot these roots in a number line. Of course, negative 10 should be here because negative 10 is less than positive 4. This will be our intervals, and we need to test a value from each one. Here I will be substituting negative 100 to our quadratic inequality, and in this interval I will be substituting 0, while in the last interval I will be choosing positive 10. These are the solutions in the testing. And as you can see, the interval here tested as true. Therefore, the solution set is this: x is less than negative 10 or greater than positive 4. The possible dimensions, particularly the width, are the positive integers between negative 10 and positive 4, because when dealing on measurement, we disregard the negative values. Add 6 to the width to get the length.